right, number 26, you have to complete the square. Solve this, you're going to get x's, but you have to do it by completing the square. You can't factor, you can't use the quadratic formula. You have to use the technique, completing the square. To complete the square, your a has to be a 1. You can't do it unless your a is a 1. So I'm going to divide everything by 3 so that I have a 1x squared. That will give me a negative 4x and a positive 8. The next step is to get your c term onto the other side. So I leave my a term, I leave my b term. I'm going to put a little box there. I subtract the 8 onto the other side, which is a negative 8, and I put a little box. This is where I'm going to complete the square. I'm going to make a perfect square over here by taking my b, halving it, and then squaring it. Half it, square it. So here's my b, negative 4. Negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. This side of the equation is a perfect square. It's going to be factored into a beautiful perfect square. But don't forget, once you added something to the left, you have to add it to the right. So that 4 is getting added on both sides. Now you have to actually factor this, and you will see a perfect square. X minus 2 times x minus 2. On the other side, I have a negative 4. And now, since I have a perfect square, I can square root both sides. I initiated the square root, so I'm going to have to take the plus and the minus. On this side, when I square rooted, it wiped out my square, just leaving me x minus 2. And on the other side, the plus and minus has to be written. And the square root of negative 4 is 2i. And now I'm almost done. I just have to add 2 to both sides to solve for my x. And my x is 2 plus or minus 2i. Notice 2 imaginary conjugates. Those are my roots. All right, number 1, quadratic. It says solve and put the answer in simplest rad form. So as soon as you see rad form, that should tell you that it's not going to be factorable. When you solve a quadratic, you always want it in standard form. Since I know it's not factorable, my only other option is completing the square, which I actually could have done. I didn't even think of it. Or the quadratic formula. I think for this problem, I'll do the quadratic. I set up my quadratic formula by doing A, B, C, 4AC. You might even want to write the quadratic formula down. X equals minus B plus or minus the square root B squared minus 4AC all over 2A. Very nice. All right, my A is the number in the front here, 1. My B is a negative 8. My C is a 4. And my 4 times 1 times 4 would give me 16. All right, so now I'm just plugging in. X equals negative 8 plus or minus the square root. Negative 8 squared is 64 minus 16 all over 2 times 1 is 2. So I get 8 plus or minus rad 80 over 2.
No, 48.
That's what I meant. 48. Wah, wah. Where's my sound effects? Sorry, I was adding. Okay, so I get x equals 8 plus or minus. Now I'm going to break up my 48. I know that there's a perfect square in 48, yes? 16 times 3. It's got to be in simplest rad form. So the square root of 16 pops out as a 4. 4 rad 3 over 2. And still not in simplest form. 8 divided by 2. And 4 divided by 2. That is the simplest form. 4 plus or minus 2 rad 3. To find the inverse of a function, which is really a reflection in the line y equal x. That's the definition of an inverse. What you're going to do is you're going to switch the domain and the range of the function. You're going to switch the x's and the y's. So in this function, where you see a y, you're now going to put an x, and where you see an x, you're going to put a y. And that really is just the inverse. It's a different line. It's the inverse line. But you're never really going to leave it in this form. You're always going to solve for y. So let me solve for y now. To solve for y, I'm going to do the opposite of subtracting 3/2. I'm going to add 3/2 to both sides of the equation. And that's going to leave me a half y on the right and x plus 3/2 on the left. And now I got to get rid of this half. I could divide by half, but instead I'm just going to multiply by 2, by the inverse. And then if I multiply this side by 2, that will wipe out my half. I have to multiply the other side by the 2. So 2 times a half cancels out to 1y. And on the other side, I'm going to distribute, and I'll get 2x plus 2 times 3/2 is just 3. And this is called your inverse function. It's like your inverse function. All right, number 9, absolute value inequality. Right away, when I see an inequality, it could be a fractional inequality, a radical inequality, or an absolute value inequality, I know that the answers I get are equal answers. I'm going to find equal answers. There may be 2 equal answers, there may be 3 equal answers, there may be 1 equal answer. I'm going to solve for my equals, and then to find the solutions for less than, I'm going to be testing points on the number line. You do that for all your inequality equations. For the absolute value, I'm going to see double, always. I take what's inside the absolute value, 2x minus 5, and I set it equal to the other side, which is 1, and the opposite of the other side, which is negative 1. And now I have like these 2 little equations that I'm trying to solve. I'm going to add 5, and I'm going to divide by 2, and I'm going to get a 3. So 3 is one of my equal answers. Then I'm going to add 5 on the other side. I'm doing this quickly. I know you guys can do this in your head. And then divide by 2, and you're going to get positive 2. That's one of your equal answers. Now, these 2 numbers aren't working in this. These are equal answers. There is no equal in this problem. So I'm going to put down my 2 and my 3. So there were only 2 equal answers. And now what I have to figure out is, where are the less than solutions? Are they in between, or are they on the outskirts? So I'm going to test, I guess I'll test the point 0. If 0 works, then the shading will be out. If 0 doesn't work, then the answers will be inside. So I'm going to test 0. And if I put 0 in, here's my little test. 2 times 0 minus 5, absolute value is less than 1. The absolute value of negative 5 is less than 1. The absolute value of negative 5 is 5. 5 is less than 1. No! So that does not work, which means my solutions are in between 2 and 3. And you could try it. You could put 2.5 in or something and test that it works. How do I write that solution? That's a graph of the solution. The way I write it is the x's are in between 2 and 3. The x's are greater than 2, but at the same time less than 3. That's how it's written. Doing number 13 on the calculator. We typed the parabola into our y1, and we go to graph. Now, clearly you can see I can't see the maximum height, so I need to adjust my windows. So the x-axis really can be adjusted too. I only have to see from 0 on, but I'll leave it there for a second. It's the y I have to go up on, the y max. So instead of 10, I'll go up to maybe 25. Oh, that's not what I wanted to do. 25. Max 25. Okay, I put my x min, let me go back. I'll put my x min as 0. Because it stands for time. You can't really have a negative time. 10 seconds. I'm scaling it by 1. My y min is height, so I can't really be below the ground. So let me change that to 0. And then I'm going up 25 feet, and I'm scaling it by 1. Ooh, that's nice. Actually, I put too much time down, right? It's a lot of time I wrote. But anyway, I want to find the max height. So now what we're going to do is second trace. Second trace. And it gives you a calculate menu. And you're going to go down to the maximum, number 4. Now, with number 4, you're going to have to move with your left and right arrows. You're going to have to move and find that blinking cursor. There it is. There he is. There he is. And you're going to go left bound, left of the max, and you're going to press enter. Then your calculator says right bound. So you take your arrows, move over to the right-hand side, and press enter. And then you're going to press enter again for your guess. And here is the max height, 20.1. And this is the number of seconds when it happened. So approximately 0.9 seconds, it hit 20.1 feet. Now, let me go to the board. Remember what it was again, but I think I did 0 to 10 on my x, and I think my y min I made 0, and my y max I made 25. You have to do a little sketch of what you see on your screen, and then your calculator direction, which was second trace number, and I think the max was 4. And then you can write the answer, which was 20.1. Okay. All right, number 17, you have to state the domain. 3 domain issues. If a function is a fraction, if a function has a radical, or if a function has a radical in a denominator. This is just a radical, and I want to know what x's can I put in. Well, I can put almost every x in, except an x that will make this radicand negative. But this x plus 3 can be positive or 0. So what I'm going to show when I do the domain is what the x's can be. When we did the one yesterday on fractions, we showed what the x can't be, because there was only 2 numbers x can't be. In this case, there's too many numbers that it can't be. So what we're going to do is just show what it can be. X plus 3 can be anything greater than or equal to 0. So if I solve this for x, x's must be greater than or equal to negative 3. So anything greater or equal to negative 3 is in my domain. Anything less than negative 3 is not in my domain. Anything less than negative 3 would make this be negative under the square root, and that's unreal. Okay, so that's your answer.